Okay, so part two, let's start with the orders of operation. So the orders of operation are important because they are all of the like rules that we follow when we first look at a basic math problem. So we have to follow these rules, right? So the first one is you need to follow parentheses, some kind of bracket or braces. So it could look like any of the above. It could also have an absolute value symbol. That's kind of a grouping symbol as well. So sometimes you see this labeled as grouping symbols in general. And then the next one would be exponents or radicals. Okay, so you got to take care of those second, and then multiply and divide, and then add and subtract. Now be careful, these two are from left to right. Okay, so you do what you see first. So let's look at problem 18 here. If we look at this problem, what should we do first? Do we have any grouping symbols or parentheses? Nope. Do we have any exponents? Nope. Do we have any multiplication or division? Yes. So we have multiplication here, and that's from left to right. We only have one, so we take care of that first. So now we're going to have 3 minus 14. Then we have our add and subtract, which we do in order. So 3 minus 14, you could again think of it like this. So it's going to be a negative 11. Okay. Now this next one, if you do it like we have in here, it's fine. You just end up with a fraction. I wrote the terms backwards. So the -4 and the -6 to the third, they should be switched if you want it to be a little prettier. So I switched it around. You could cross yours out and switch yours around as well. So let's look at this problem. And what do we see first? We don't really see a parenthesis. We do, but this parenthesis just has a number inside. We don't have anything to simplify in either parenthesis. Okay, so parentheses could also just be a way to put something to a power or to times things. So as long as it's down to a number, you're good. You've taken care of the parenthesis. The next step was exponents. So we do see two exponents here. So let's take care of that. We have 6 outside. What is -2? It's the full -2 squared. Be careful. This is not the same as this. I know that's a tricky thing in math, right? This is like ignore the negative, square, it becomes, and it stays negative. This is like square the full negative so it becomes positive. So the answer is 4 and -4. Let's put that on here in case you want that in your notes. This answer would be -4, whereas this answer would be +4. So if you put it in your calculator without the parentheses and you're in a hurry, you're going to get the wrong sign and it's going to mess up your answer. So be careful of exponents of negatives and if you have a parenthesis or not. If it just said x squared as well and you're plugging in -2, that is like this one because you're squaring that full number. Okay, so -2 squared is going to be +4. I'll leave it in a parenthesis. That just means times now. And then plus -6 to the third is the same as -6 times -6 times -6. So -6 times -6 is a +36 times a -6. I'm going to crack out my calculator. What is that, 216? 36 times 6 is 216. So -216. Oh my goodness, did you see what I wrote? Okay, so this is going to become -216. I don't need the parenthesis. I can put it there. I don't need it. Divided by -4. Okay, so we took care of parentheses, exponents. Now we have to multiply or divide like we're reading. So the first one I see is 6 times 4. So 24 here plus, and then we have this -216 divided by -4. Could be written like this. You don't really need the parentheses. And then we do the division. Okay, we did the times first because it's from left to right. And the division, 216 divided by 4 is, I don't know, 54. So what is a negative divided by a negative? A positive. So we're going to have 24 plus positive 54 when we do that division. Now we're to add, subtract, and 24 and 54 make 78. So our final answer is 78. Just for fun, well, I don't think it matters. Okay. So number 20, our parentheses are a little weird, just the way this came up on my iPad, and this page thing is weird, just ignore it. I can delete it for a second and then it'll come back. Okay, so looking at this one, we do have parentheses. We have that 7 minus 9 in a parenthesis, and then here's another parenthesis, right? So when we have two parentheses, start with the inside one and then work your way out. So I'm going to leave the negative 3 squared plus 2 parenthesis 8 divided by, and I'll take care of 7 minus 9 is what? Negative 2. Okay, so I took care of the first parenthesis. I could have left it in a parenthesis, like a negative 2 in a parenthesis. It wouldn't have mattered. It would just been a number. Okay, then from here, we got to do the division, or the division. So negative 3 squared plus 2. What is 8 divided by 2? Now it's a negative and a positive, so it's going to be a negative, and 8 divided by 2 is 4. Okay, so we're here. Now we've gotten rid of the parentheses, we can do our exponent. So this is 1. Is this going to be a positive when we do negative 3 squared 9, or a negative 9? Negative, because it's like, ignore this, 3 squared's 9, and then bring in the negative. Another way that some teachers teach it is it's like negative 1 times 3 squared. That helps you. So this becomes just 9, keeping the negative. And then you have plus the 2 times the negative 4. So our next step would be then the times piece. So 2 times the negative 4, because of parenthesis. So now I'm at negative 9 plus negative 8, because 4 times 2 is 8, and it's negative, because one of them's negative. And if I'm at negative 9 and I minus off 8 more, I'm at negative 17. Final answer. Okay, so that's orders of operation. Okay, let's do a little reminder of some fractions. All right, so you'll notice I wrote something on paper and put it on here. So fractions, how to reduce a fraction. So we want to look at reducing first. So we look at a fraction, and these are just examples, and we think, okay, 18 over 24, I can reduce that. So one way is divide the top and bottom by the same number. Okay, so like these ones are easy to look at and be like, well, they're both divisible by 2. Oh, good, now I'm at 9/12. Oh, 3 goes into both of those. Divide by 3, I'm at 3/4. That's the lowest we can go. Or you were like, oh, 6 goes into the original, which would bring you straight to 3/4. So you divide the top and bottom by the same number. Another method is using your trees. So let's say that you just are really struggling with if something can be reduced. This is one way to do it. So I take the 18 and do our tree, right? And do our prime factors, 24 prime factors. And then I write them out and cancel the common factors and multiply what's left. There's another method. Okay, I like this method more when I just really have no clue. Like sometimes they have like a 13 in common, and you would have never thought of that because it's a prime number in strange, or 17 or something like that. Okay. It definitely wrote my fractions weird, but that's all right. We'll deal with it. I'm going to have to make sure I make these PDFs so they don't do this again. All right, so we look at this. We have 19/5 and 3 4/5. So I'm going to rewrite this for you. This should be 19/5. Cross that out. And this should be 4/5 like that. Cross that out. There we go. It's like way high. So an improper fraction is where the top is bigger than the bottom, and a mixed fraction is where you have a number in front and a fraction, like 19/5. So we can make that a mixed fraction. So they can be equal to each other, but 5 goes into 19 3 times with 4/5 left over. That's where this comes from. Again, 5 goes into 19 3 full times. That gets you to 15, but you have 4 more to get to 19 fifths. So those are the same number written, and just remembering what is a mixed fraction, what is an improper, especially for MyMathLab with the way it wants you to enter your answer. Typically, it will ask for an improper fraction on a lot of our solutions, but it could want a mixed fraction. Okay. What if I wanted the decimal? Well, the decimal is just divide the top by the bottom, and that's going to give us 3.1 or 3.18. There's no one. 3.8. Okay. So 4/5 as a fraction is 0.8. Okay, because a decimal and fraction are just different ways to write the same thing. A piece of something, not a whole. So that is where that comes from. So you just divide. Okay, so what if I want to go decimal to a fraction? Okay, so if I have, I hate this, that's okay. If I have 48, or excuse me, 0.048, I'm just going to look at that. I go out 1, 2, 3 places, right? And that is tenths, hundredths, thousandths. So it's in the thousands place. So that's where I'm going to write it as 48 over 1,000. And then I reduce that fraction until, you know, as low as we can get on that fraction. So when I reduce that one, you could do it a couple ways. I could start with 2 and divide. I could get the prime factors and cancel those out as well. But I would start with, well, I could start with 4 really, because 48 is divisible by 4. So I'm going to divide both the top and bottom by 4 and get 12. What is 1,000 divided by 4? It is 250. And then and that's dividing the top and bottom by 4. Okay, and then 12 and 5, 6, 7. So they're not both divisible by 3. I was just thinking only 2. That's all I can think of right now. So half of both is going to get me 6 over 125. Yeah, and that's probably because 2 and 3 are the only thing that go into 6, and 2 and 3 don't go into 125. So there's our reduced fraction. So that's how you can go from a decimal to a fraction. You basically are putting it over tens because it's tenths, or 100 if it's in the hundredths place, or 1,000 like this one because it was in the thousandths place. Okay. And then from here, I'm going to pause for a sec. Okay, so we've converted a decimal to a fraction in one setting. Okay, so it's a little harder when you have a repeating decimal or fraction, right? So what if it's repeating? How am I going to take care of that? So here is kind of the way it works. It is a little bit tricky. So when I think of converting 0.3, and I couldn't figure out the line, so just draw the little line over the top. If I want to convert 0.3 repeating forever, how am I going to convert that? Well, I know it's 1/3. How am I going to get that as my solution? Here's how it works. We magically say n equals 0.3 repeating. Okay. Then we're going to times both sides by 10 because it only goes out tenths place. If it went out the hundredths place, then you times by 100. So I'm going to times both sides by 10. Okay, following. Times both sides by 10. Now I'm going to subtract n from both sides, but I'm going to do a different n on both sides. When I subtract in here, I will have 10 minus 1 n is 9 n's. But when I subtract here, I'm going to subtract the 0.3 repeating version of n. They're both n, but I'm subtracting a different one from both sides. So this side is just 3. Now I'm going to solve for n by dividing by 9, because that's what's by the n, and I get 3/9. Okay, if I reduce 3/9, divide both top and bottom by 3, I get the 1/3. So I magically set it equal to n times by whatever number, 10, maybe 100, because the next one will be 100, and then divide, and I have this solution. So you'll kind of see like this side over here ends up being like 9 or 99, and this side over here ends up being what was repeating divided by that. So it's kind of a pattern that you could get pretty easy converting once you've done it a couple times. So 0.53 needs to have a line over the 5/3. So this goes repeating 0.53, 0.53, 0.53, right? Or not 0.53535353, and it keeps going. So if I convert this one, I'm going to do the same thing. So let n equal 0.53 repeating. And then this time I'm going to times by 100 because it goes out 2 decimal places, the repeating piece. So 100 times n, and 100 over here would get me this, right? Then I minus the n from both sides. Okay. And this would be 99, and this would be 53. So what's your solution? Your solution is 53 over 99. Divide both sides by 99. Totally tricky. So what repeated? 53 over 99. What repeated? 3 over 9. See my pattern? Okay. Add or subtract with fractions. So when I go to add or subtract with fractions, you have to have a common denominator. This is written so pretty. So 2 tenths plus 3 7/10. All right, so on this one, I kind of have a common denominator a little bit because it's the tenths and tenths. I wrote that a little bit strange, but the tricky part, this one I can't even talk today. Maybe I should make videos. Okay, so if I think about this one, I can actually add it right now because the fractions have a common denominator already, the 10. So I could just say 2 plus 7 is 9/10. So I can go, okay, I only have the whole of 3. I didn't have another whole to add that to, and 9/10. Another way I could have done the same problem is make it improper. This one was a little easier to see, but sometimes you won't be able to see that very well. Oops, this should be a plus. Over here, go 3 times 10. That's going to be 30 plus the 7. So 3 times 10 plus the 7 is going to give you your top number. So 37 tenths. So you probably have to make a lot of your mixed fractions improper to be able to get the right answer. I mean, this one worked out pretty well, but if that would have been up here, would have been like 4 or 5, then you would have had an extra one to try to add here. It adds some extra steps that make it a little bit harder. So I make it improper, then I just add straight across, and I get 39. Keep your common denominator. You work hard for it, so you keep it. And I would get 37 plus 2 for the top over your common denominator, which these are the same number. They equal the same thing. 10 goes into 39, 3 and 9/10. So, and you could be able to do improper solution. So either way. So there's 2 methods for that one. Okay, so for this one, I have 1/15 minus 7/24. And on this one, I do need to get a common denominator. So if I look at 15 and 24, what number do they both go into? Well, we worked on this in the last video. We were like, we could get the common multiple, right, that they both divide into. So we could do trees to try to get that. We could play with numbers. So I'm going to go up here and just make a tree. So we have 15, so that's 3 times 5. And we have 24, and that one's a hard one. 2 times 12. You could have 4 times 6. There's lots of ways you could have started. And then 2 times 6, and then 2 times 3. All right, so a common multiple took every number but what's in common once. So we're going to take 3 times 5 from the 15. And then, so everything. And on the 24, we don't need to add the 3 again, but we have to do the 3 2s. So 2 times 2 times 2, and I'm going to multiply that together. So 3 times 5 times 2 times 2 times 2 is 120. That's why you learned that, really. Okay, so I'm going to use 120 as my common denominator. So to get 120 for the first fraction, I'm going to times the top and bottom by 8, because 8 times 15 gets me to the 120. 120 divided by 24 is 5. Okay, and then 5 on this one. So I'm going to times that one by 8 and that one by 5, and I will have my common denominator. So that's going to give me 8 over 120 minus 7 times 5 is 35 over 120. Now I keep the common denominators and I add or subtract the top. So 8 minus 35 is negative 27. Right, there's our method. Then 27 over 120, it is divisible by 3. Because I went 1 plus 2 is 3. So I know 3 goes into this one, 7, 8, 9. So 3 goes into 27, plus I just know 3 goes into 27. Okay, so if I divide the top and bottom by 3, I'm going to get negative 9 over 40. And that's now my reduced fraction. All right, so add, subtract, that's just a little quick reminder. If you still struggle with fractions, you could work on them. Like you could always look at like Khan Academy or something else too, where they have practice problems if you need. The book probably has extra problems as well if you want. So let's look at times and multiplication. So when I look at this one, I'm going to have negative 2 over 5 times negative 15 over 4. And I am going to just times straight across. So when I times, I just times the tops and bottoms. I don't have to have a common denominator and then reduce. I can also look at cross cancellation if you want. So I can look at, can I divide across with the same number and reduce? So anything on the top with anything on the bottom before I multiply. It just makes reducing a little bit easier. So what I'm going to do is think of, well, I can divide this one by 2 and this one by 2. And I could divide this one by 5 and this one by 5. And that will make it easier. And the number's less big, I guess. So when I do that, I'm going to have negative 1 here. 5 divided by 5 is 1 here, times negative 15 divided by 5 is negative 3, and 4 divided by 2 is 2. Okay, and now if I multiply straight across, I'm going to get positive 3 over 2, or 3 halves. And so pretty cool. I could just time straight across though, and I could have gotten negative 2 times negative 15 is positive 30. 5 times 2 is 20, and then reduce that fraction down. So you can deal with the big numbers, that's fine, but cross canceling is great. Or you could cancel like this one, I'm dividing both top and bottom by 10, right? Or you could cancel in that second step. Either way that you like to do fractions works for me. Okay, what happens if they're a mixed fraction? So 7 and 1/3, I want to times it by 5 and 3/4. Then you need to make them improper. Like it's not going to work this way. You can't times this way. So we're going to do 7. Well, you can, but it's super hard. So we're going to do 7 times 3 is 21 plus 1 is 22/3. Okay, and 5 times 4 is 20 plus 3 is 23/4. Okay, so I made them improper. Now I'm going to time straight across, but definitely want to look if I can cancel any common factors. I see one of 2 here. That's the only one I see. So this one will become 11, and this one would become 2. I don't see 23 and 3, you can't do anything. Okay. So then I made the number somewhat smaller. So 23 times 11 is going to give me 253, and 3 times 2 is 6. So that could be your solution. What if they want it mixed? How many times does 6 go into 253? So I'm going to divide them on my calculator. I have the decimal now, 42.16666 repeating. And what I'm going to do is I'm going to keep the 42. I know it goes in at least 42 whole times. And then I'm going to do 6 times 42. And that gave me 252. Okay. So 6 times 42 is 252. How many more do I need to get to the 253? 1. So I have 1 remaining out of 6. 1 6. And you can divide the 1 6 and make sure the decimal matches the 42.1666 repeating. That is 1 6. Okay, so this is your final answer. This could have been as well, just depends on the notation that it wants. Okay, so division. If I have 12 over 4 divided by 10/7. With division, we're just flipping the second or the bottom one, if it would have been written like top over bottom. So I'm going to have 12/4, and I'm going to flip the second one and make it 8 times problem. So they're really the same thing. You just flip the second and then times. Okay, so then we can again look at any cross canceling. I can see 10 and 12 are both divisible by 2. I can also see that 2 goes in here and here, leaving a 3 and a 2. So you can reduce that way as well. Oops. And then times straight across. So 3 times 7 is 21. 2 times 5 is 10. So I have 21 tenths, which 10 goes in there 2 times with 1 extra. So 2 and 1/10. Either one is fine. All right, so division. Okay, almost done with the basic reminders from algebra, right? So, or 900. So if we have a square root, just real quick, reminding yourself that the square root of a number is like undoing a square. So if I know 5 times 5 is 25, then when I go to do the square root of 25, it's going to go back to 5. So if I have the square root of 49, what's the solution? 7 times 7 is 49. So the solution is 7. What if I have the square root of 15? You can't reduce it. It's a decimal, right? 15 isn't a perfect square. The perfect squares go 4, because that's 2 times 2, 9, 16, 25, 36, 49, 64. I could keep going for a while. So this one is a decimal. So we would go, okay, we could put it in our calculator. The square root of 15 is about 3.87. So not an exact answer. Okay, the last major idea for this section is going to be on sequences. Okay, a sequence is a pattern or an order of numbers where three dots represents that the pattern just keeps going. So it's all about patterns, and that's what math is. It's patterns, a lot of patterns. So looking at our first type of sequence, we have arithmetic sequence, and this is where you're adding or subtracting a number each time to get to your next number. So I'm looking at this sequence right here. The sequence is 5, 9, 13, 17, right? So I'm going up 4 each time. So I did this little thing to show you I'm going up 4 each time. The sequence could be going down, okay? 20 to 17 is down 3, 17 to 14 is down 3. And so we're decreasing. So we have a negative, okay? We call this 3 or this 4 a common difference. All right. The book labels those as CD or little d. It depends. Common difference, just the difference between them. Here's some notation stuff. We let A1 equal that first term in your sequence, A2, A3, A4. So if I wanted A100, I would have to follow the pattern to get to A100. Okay. So that's the general formula. This is the main idea. And then the last thing is our general formula. If I wanted that hundredths number, I need a formula because I don't want to write out 100 numbers. I'm just too lazy. So here is the formula. So what the formula says is for any number in the term, any term, that's what term is here, you use the first term plus the difference between them times the next spot in the term. So n minus 1 is this, it's because it's the next spot in the term. So what do you have to know to write the general formula? You have to know the first spot. Where are you starting in your sequence? Because I could be adding 2, but what if I start with the number 1 or I start with the number 5? I have to know where my sequence is starting. So you have to know the first number and then what is the difference between each one. So you have to know both of those. Okay, so look at this problem. We're going 29, 31, 33, 35, 37. Take a second. How do I get from 29 to 31? Okay, good. I'm just adding 2, correct? Just adding 2. All right, so the common difference is going to be a positive 2. And really, you could think of it like this, like I did on the other thing. Oops, plus 2, plus 2. And you have to keep checking. You can't just look at the first 2 numbers because not all of them are arithmetic where they add the same one. Not all of them are going to be what we call geometric where they multiply. Some are just weird patterns. And or like the Fibonacci sequence or something. So like you have to check that it follows that plus 2 for every number you see. Okay, so what is A1? What did A1 represent? It represented the first number in the sequence, which is 29. Okay, if you followed this pattern, what would be the next 2 terms in the sequence? Well, I'm at 37, so 37 plus 2 is going to be 39, and then 39 plus 2 would give me 41. So those are the next 2 numbers in that sequence. Now, what would be the formula? So the formula says A of n always is going to equal the first term. What was our first term? 29 excuse me, and then 2 was our difference times n minus 1. And that's it. That's your, you could simplify this. I'm excited if you just write that. Okay. Simplified, just in case you have to do that in your homework. I don't think so. You times the 2 here. So simplified, I would have 29 plus 2n minus 2. And then I could combine the numbers and have 2n, 29 minus 2 is 27. And that's our a sub n equals this. So this, or this, those are the same thing. One's just simplified. Okay. So check this out though. Just think through this real quick. I'm going up by 2's. And I had to start at 2 below the first one to be able to follow the pattern. So it's like getting that's really the logic of it. And that's used to be how I would teach it. But now I try to follow the book on this one and follow the pattern, or follow their formula they give you. Oh, get yourself yawning. All right, last one. What's the 50th term? So this is how you're going to use this formula. N stands for the term number. So if I want the 50th term, I literally put in 50. So it's going to go 2 times 50 plus 27. You could have put the 50 here too. If you use that formula, it would have worked just fine. And this is now a sub 50 equals this. So 2 times 50 is 100. 100 plus 27 is 127. Ooh, I know sequences can be harder. Okay, so on your homework, some of them you're just following the pattern and writing the next 2 terms. Sometimes you're doing all of the stuff I just gave you. Just kind of depends. Okay, so the next one is called a geometric sequence. And this right here should say R equals A2 divided by A1 right here. Okay, and this part is just A to the N over A to the N minus 1. Okay, and that N and N minus 1 are like subscript. Okay. All right, so geometric sequence. You're actually going to multiply, obviously not by 0, each previous term by something. So a geometric sequence gets big, and it gets big really fast. So we're timesing for a geometric sequence. How would I find what you're timesing by? Is you take the second term divided by the first term. That's where this comes in. Second term divided by the first term. That's how you can figure out your difference. I mean, your ratio. And we call this a ratio with little r. Because the ratio is like, what is the ratio is like the multiplication. It's like a fraction that, yeah, I don't know how to explain a ratio very good, do I? Yeah, because to me, I just make sense. Just a fraction that relates them, or a number. Okay, let's look at some examples. So look at these 2 examples. So my sequence went 4, 12, 36, 108. So when I first look, I go, okay, I'm going to add what to get to the next one? Oh, 8. But then I go to look and I go, oh, 8 doesn't work here. So that's how you start. Like, I always look for arithmetic first and then be like, oh, nope. Am I then timesing? Oh yeah, 4 times 3, 3 times 12, 36 times 3, and so forth. And you might have to do the proportions to figure out that it is 3. So this one divided by this one, this one divided by this one, this one divided by this one. Better all give you that solution of 3. So our ratio is 3. Okay, this one, it's going down, but it's definitely not by the same number, because that's 4, that's 2, that's 1. So again, 4, second one, divided by this one. 4 divided by 8, right? 4 divided by 8 is 1/2. Is 2 divided by 4 also 1/2? Yes. Is 1 divided by 2, which is 1/2? Yes. Is 1/4 divided by 1/2? 1/2? Yes. Or excuse me, I said it backward. 1/2 divided by no, I said it right. 1/4 divided by 1/2. Okay. All right. So the general formula for this one is first term ratio number to the power of n minus 1. All right, let's look at this first geometric sequence. So find the common difference. This should really say ratio. Okay, what is the ratio? Well, I'm going from -6 to negative 24. Definitely not subtracting or adding the same number each time. So 6 times what? So I would go -24 divided by -6. What is -24 divided by -6? +4. Okay, if I do 96, so -96 divided by -24, do I also get 4? Yes. So I'm multiplying by a +4. Now, if you are multiplying by a negative number, it has to switch signs. It would have to go negative, positive, because that's how it works when you're timesing by negatives, is every other one is going to be positive. So because you would end up with a double negative, like negative times a negative, then you get a positive, then the next one would be a negative, and so forth. So what is our ratio? Our ratio is 4. Okay, and we call that little r if you want. What is the first term? A sub 1, our first term is -6. What's the next two terms? So I'm going to have to use my calculator. What is -384 times 4? It's big. -1,536, and then times that by 4, and I get -6,144. So getting bigger and bigger and bigger fast because we're multiplying. And then what's the general formula? So the general formula, A sub n, is going to equal the first term, -6, and then times that by the ratio, which is 4 to the n minus 1. You definitely can't simplify these, so it's even easier. Done. You cannot combine the 4 and the 6 because the 4 has an exponent, so you can't combine those. So how would I do the 50th term? I know A sub 50 represents 50th term, and I would go -6 times 4 to the 50th minus 1. And so that's the 49 there. So I'm going to have to put this in my calculator. -6, oh, it's going to be so big. I don't even think it can do it. Times 4 to the power of 49. Yeah, scientific notation. That's what it gave me. Okay, see that E in there? That's just saying take it to the power of 30. So my answer is -1.9 and then a bunch of decimals times 10 to the 30th power. Ew. This is just too big. So I don't think your homework will ask for the 50th term on a geometric sequence. I think it'll be more like use your formula to find the 8th term or something like that. Or just find the formula. Just being able to do that is important because the formula allows you to put in the term place and get your answer. So that's great. All right, that's really the main idea for this chapter 1 and 5 review. It's like some basic algebra, remembering your negatives and your positives, you add, subtract, remembering those fractions, and then the sequences is probably the first thing that might be new to you. Okay? All right. Talk to you soon.